quadratic equation in the variable x is an equation of the form ax square plus bx plus c is equal to 0, where a, b and c are real numbers and a is not equal to 0. Here is an example of quadratic equation. 5x square minus 3x plus 3 is equal to 0. This power 2 of variable x makes the equation quadratic. The name quadratic comes from quad, meaning square, because the variable gets squared like x square. But sometimes a quadratic equation is not in its usual form. This is a quadratic equation in disguise. Move all terms to left-hand side and you have the equation in the standard form. In standard form, the equation is x square minus 3x plus 1 is equal to 0, where a is equal to 1, b is equal to minus 3 and c is equal to 1. Next quadratic equation in disguise is 5 plus 1 upon x minus 1 upon x square is equal to 0. Multiply by x square on both sides. And here we have the standard form. 5x square plus x minus 1 is equal to 0, where a is equal to 5, b is equal to 1 and c is equal to minus 1. Represent this situation mathematically. A cottage industry produces a certain number of toys in a day. The cost of production of each toy in rupees was found to be 55 minus the number of toys produced in a day. On a particular day, the total cost of production was rupees 750. We would like to find out the number of toys produced on that day. Let's represent the given situation mathematically. Let the number of toys produced on that day be x. Therefore, the cost of production in rupees of each toy that day is equal to 55 minus x. So, the total cost of production in rupees that day is equal to x into 55 minus x. Therefore, x into 55 minus x is equal to 750. This implies 55x minus x square is equal to 750, which implies minus x square plus 55x minus 750 is equal to 0. Multiply both sides by minus 1. This gives x square minus 55x plus 750 is equal to 0. Therefore, the number of toys produced that day satisfies the quadratic equation x square minus 55x plus 750 is equal to 0, which is the required representation of the problem mathematically. In this module, we will learn solution of a quadratic equation by factorization. In general, a real number alpha is called a root of the quadratic equation ax square plus bx plus c is equal to 0, where a is not equal to 0. If a alpha square plus b alpha plus c is equal to 0, we also say x is equal to alpha is a solution of the quadratic equation, or that alpha satisfies the quadratic equation. Always remember that the zeros of the quadratic polynomial ax square plus bx plus c and the roots of the quadratic equation ax square plus bx plus c is equal to 0 are the same as roots and solution of the equation. We also know that a quadratic polynomial can have at most 2 zeros. So any quadratic equation also can have at most two roots. Let us find the solution of a quadratic equation by factorization using algebraic identities. Suppose we wish to solve 3x squared is equal to 27. We begin by writing this in the standard form of a quadratic equation by subtracting 27 from each side to give 3x squared minus 27 is equal to 0. We now look for common factors. By observation, there is a common factor of 3 in both terms. This factor is extracted and written outside a pair of brackets. The contents of the brackets are adjusted accordingly. 3x squared minus 27 is equal to 3 into x squared minus 9 is equal to 0. Notice here the difference of two squares which can be factorized as 3 into x squared minus 9 is equal to 3 into x minus 3 into x plus 3 is equal to 0. If two quantities are multiplied together and the result is 0, then either or both of the quantities must be 0. So either x minus 3 is equal to 0 or x plus 3 is equal to 0. So that x is equal to 3 or x is equal to minus 3. These are the two solutions of the equation. Now we will find the solution of a quadratic equation by splitting the middle terms method of factorization. Let us solve x squared minus 5x plus 6 is equal to 0. Here we will make use of splitting the middle term. We factorize the quadratic equation by looking for two numbers whose product is 6 and the sum is minus 5. Now, minus 3 into minus 2 is equal to 6 and minus 3 plus minus 2 is equal to minus 5. So the two required numbers are minus 3 and minus 2. We use these two numbers to write minus 5x as minus 3x, minus 2x and proceed to factorize as follows. X squared minus 5x plus 6 is equal to 0, which implies x squared minus 3x minus 2x plus 6 is equal to 0. This implies x into x minus 3 minus 2 into x minus 3 is equal to 0. This gives x minus 3 into x minus 2 is equal to 0, from which x minus 3 is equal to 0 or x minus 2 is equal to 0, so that x is equal to 3 or x is equal to 2. These are the two solutions. Solution of a quadratic equation by completing the squares. In this module, we will learn about solution of a quadratic equation by completing the square. Solving quadratic equations by completing the square. General form of quadratic equation is ax squared plus bx plus c is equal to 0. Where a is coefficient of x squared, b is the coefficient of x and c is the constant term. Let us solve it by completing the square. Solving a quadratic equation by the method of completing the square can be divided into following steps. Step 1. Divide all terms by a, the coefficient of x squared. Step 2. Move the number term c upon a to the right side of the equation. Step 3. Complete the square on the left side of the equation by adding whole square of b upon 2a and balance this by adding the same value to the right side of the equation. Step 4. Complete the squares by making use of identity whole square of a plus b is equal to a square plus 2ab plus b square. Step 5. Take square root on both sides of the equation. Step 6. Solve for x once taking the value on RHS as positive and once negative. Let us take an example for better understanding. Solve the quadratic equation by completing the square. 2x square minus 5x plus 3 is equal to 0. Let us solve. Here, a is equal to 2, b is equal to minus 5 and c is equal to 3. First step, divide throughout by 2 as here coefficient of x square a is equal to 2. We get x square minus 5 upon 2x plus 3 upon 2 is equal to 0. In second step, moving c upon a, that is 3 upon 2 to the right side, we get x square minus 5 upon 2x is equal to minus 3 upon 2. In third step, complete the square. Add whole square of b upon 2a, that is whole square of 5 upon 2 into 1 upon 2 is equal to 25 upon 16 to both sides of the equation. We get x square minus 5 upon 2x plus 25 upon 16 is equal to minus 3 upon 2 plus 25 upon 16. In step 4, write the left-hand side as perfect square using the identity whole square of a plus b is equal to a square plus 2ab plus b square and simplify right-hand side. We get whole square of x minus 5 upon 4 is equal to 1 upon 16. In step 5, taking square root on both sides, we get x minus 5 upon 4 is equal to plus minus 1 upon 4. In step 6, solve for x once taking the value of RHS as positive and then as negative. Therefore, x minus 5 upon 4 is equal to plus minus 1 upon 4. Moving 5 upon 4 to the right side, we get x is equal to 5 upon 4 plus minus 1 upon 4. This gives x is equal to 5 upon 4 plus 1 upon 4 or x is equal to 5 upon 4 minus 1 upon 4, which implies x is equal to 3 upon 2 or x is equal to 1. Therefore, the solutions of the equations are x is equal to 3 upon 2 and 1. Solution of a quadratic equation by quadratic formula. Consider the general form of quadratic equation ax square plus bx plus c is equal to 0, where a is not equal to 0. Dividing throughout by a, we get x square plus b upon a into x plus c upon a is equal to 0. By completing the square, we get whole square of x plus b upon 2a minus whole square of b upon 2a plus c upon a is equal to 0. By simplifying it, we get whole square of x plus b upon 2a minus b square minus 4ac upon 4a square is equal to 0. So the roots of the given equation are the same as those of whole square of x plus b upon 2a is equal to b square minus 4ac upon 4a square. This is equation 1. If b square minus 4ac is greater than and equal to 0, take square root on both sides of the equation. X plus b upon 2a is equal to plus minus under root b square minus 4ac upon 2a. This gives x is equal to minus b plus minus under root b square minus 4ac upon 2a. So the roots of ax square plus bx plus c is equal to 0 are minus b plus under root b square minus 4ac upon 2a and minus b minus under root b square minus 4ac upon 2a if b square minus 4ac is greater than and equal to 0. If b square minus 4ac is less than 0, the equation will have no real roots. Thus, if b square minus 4ac is greater than and equal to 0, then the roots of the quadratic equation ax square plus bx plus c is equal to 0 are given by minus b plus minus under root b square minus 4ac upon 2a. This formula for finding the roots of a quadratic equation is known as the quadratic formula. Let us explore this concept with an example for better understanding. Find two consecutive odd positive integers, sum of whose square is 290. Let the smaller of the two consecutive odd positive integers be x. Then the second integer will be x plus 2. According to the question, x square plus whole square of x plus 2 is equal to 290. That is, x square plus 4x plus 4 is equal to 290. Which gives 2x square plus 4x minus 286 is equal to 0. Dividing throughout by 2, we get x square plus 2x minus 143 is equal to 0, which is a quadratic equation in x. Here, a is equal to 1, b is equal to 2, and c is equal to minus 143. And the quadratic formula is minus b plus minus under root b square minus 4ac upon 2a. Using the quadratic formula, we get x is equal to minus 2 plus minus under root 4 plus 572 upon 2, which is equal to minus 2 plus minus under root 576 upon 2. Taking square root of 576 is equal to 24, we get minus 2 plus minus 24 upon 2. This gives us x is equal to 11 or x is equal to minus 13. But in the question, x is given to be an odd positive integer. Therefore, x is not equal to minus 13. X is equal to 11. Thus, the two consecutive odd integers are 11 and 13. Let us check the answer. Square of 11 plus square of 13 is equal to 121 plus 169, which is indeed equal to 290, which is also same as given in question. We also know that by quadratic formula, the roots of the equation ax square plus bx plus c is equal to 0 are given by x is equal to minus b plus minus under root b square minus 4ac upon 2a. Now let us discuss the nature of roots. If b square minus 4ac is greater than 0, we get two distinct real roots minus b upon 2a plus under root b square minus 4ac upon 2a and minus b upon 2a minus under root b square minus 4ac upon 2a. If b square minus 4ac is equal to 0, then x is equal to minus b upon 2a plus minus 0, that is, x is equal to minus b upon 2a or minus b upon 2a. So the roots of the equation ax square plus bx plus c is equal to 0 are both minus b upon 2a. Therefore, we say that the quadratic equation ax square plus bx plus c is equal to 0 has two equal real roots. And if b square minus 4ac is less than 0, then there is no real number whose square is b square minus 4ac. Therefore, there are no real roots for the given quadratic equation. Since b square minus 4ac determines whether the quadratic equation ax square plus bx plus c is equal to 0 has real roots or not, b square minus 4ac is called the discriminant of this quadratic equation. So a quadratic equation ax square plus bx plus c is equal to 0 has two distinct real roots if b square minus 4ac is greater than 0, two equal real roots if b square minus 4ac is equal to 0, no real roots if b square minus 4ac is less than 0. Let us take an example of real life to understand the concept more clearly. A pole has to be erected at a point on the boundary of a circular park of diameter 13 meters in such a way that the difference of its distances from two diametrically opposite fixed gates A and B on the boundary is 7 meters. Is it possible to do so? If yes, at what distances from the two gates should the pole be erected? Let us first draw the diagram. Let P be the required location of the pole. Let the distance of the pole from the gate B be x meters. That is, BP is equal to x meters. Now, the difference of the distances of the pole from the two gates is equal to AP minus BP, or BP minus AP is equal to 7 meters. Therefore, AP is equal to x plus 7 meters. Now AB is equal to 13 meters. And since AB is a diameter, angle APB is equal to 90 degrees. Therefore, by Pythagoras theorem, AP square plus PB square is equal to AB square. This implies whole square of x plus 7 plus x square is equal to 13 square, which gives x square plus 14x plus 49 plus x square is equal to 169. This gives the equation 2x square plus 14x minus 120 is equal to 0. Dividing throughout by 2, we get x square plus 7x minus 60 is equal to 0. So the distance x of the pole from gate B satisfies the equation x square plus 7x minus 60 is equal to 0. So it would be possible to place the pole if this equation has real roots. To see if this is so or not, let us consider its discriminant. The discriminant is b square minus 4ac is equal to 7 square minus 4 into 1 into minus 60 is equal to 289, which is greater than 0. So the given quadratic equation has two real roots, and it is possible to erect the pole on the boundary of the park. Solving the quadratic equation x square plus 7x minus 60 is equal to 0, by the quadratic formula we get x is equal to minus 7 plus minus under root 289 upon 2, which is equal to minus 7 plus minus 17 upon 2. Therefore, x is equal to 5 or minus 12. Since x is the distance between the pole and the gate B, it must be positive. Therefore, x is equal to minus 12 will have to be ignored. So, x is equal to 5. Thus, the pole has to be erected on the boundary of the park at a distance of 5 meters from the gate B and 12 meters from the gate A.
Examples of quadratic equations. Let's take an example. Find the nature of roots of the quadratic equation 2x squared minus 6x plus 3 equal to 0. If the real roots exist, find them. Let's solve this. Here, a is equal to 2, coefficient of linear term b is equal to minus 6, and constant term c is equal to 3. So, the discriminant is equal to b square minus 4ac is equal to minus 6 square minus 4 into 2 into 3 is equal to 36 minus 24 is equal to 12 greater than 0. Therefore, the roots of the equation are real and unequal. The roots are given by the formula x is equal to minus b plus minus under root b square minus 4ac divided by 2a is equal to minus minus 6 plus minus under root 12 divided by 2 into 2 is equal to 6 plus minus under root 4 into 3 divided by 4 is equal to 6 plus minus 2 root 3 by 4 is equal to, cancelling 2 in the numerator and denominator, 3 plus minus root 3 by 2. Therefore, roots are 3 plus root 3 by 2 and 3 minus root 3 by 2. Important point to note here is, here the roots are irrational because the discriminant was 12, which is not a perfect square, and 2, minus 6, 3 are rational numbers. Let's take the next example. Solve under root 3x squared minus 2 plus 1 is equal to 2x. Let's solve this. Taking 1 on the other side, we'll have under root 3x squared minus 2 is equal to 2x minus 1. Squaring both sides to remove radical, 3x squared minus 2 is equal to 2x minus 1 whole square. This implies 3x squared minus 2 is equal to 4x squared minus 4x plus 1. Or, on simplification, we'll have x squared minus 4x plus 3 is equal to 0. This implies x squared minus 3x minus x plus 3 is equal to 0. This implies, taking x common from the first two terms, we have x into x minus 3. Taking minus 1 common from the last two terms, we have minus 1 into x minus 3 is equal to 0. Or, x minus 3 into x minus 1 is equal to 0. This implies x minus 3 is equal to 0 or x minus 1 is equal to 0. This implies x is equal to 3 or x is equal to 1. We have to check the answer because we have squared both sides. When x is equal to 3, we get under root 3 into 3 square minus 2 plus 1 is equal to 2 into 3. That is, under root 25 plus 1 is equal to 6, which is true. When x is equal to 1, we get under root 3 into 1 square minus 2 plus 1 is equal to 2 into 1. That is, under root 1 plus 1 is equal to 2, which is once again true. Therefore, solutions are x is equal to 3 and 1. Important point to note here is, by squaring both sides of under root 3x square minus 2 is equal to 2x minus 1, as well as that of under root 3x square minus 2 is equal to minus 2x minus 1, we get the same resulting equation x square minus 4x plus 3 is equal to 0. Hence the roots of x square minus 4x plus 3 is equal to 0 may be roots of under root 3x square minus 2 equal to 2x minus 1 or under root 3x square minus 2 is equal to minus 2x minus 1. In such cases, we check the correctness of the answer as shown above. Solving word problems using quadratic equations. Let's take an example. The sum of the squares of three consecutive integers is 110. Find the integers. Let's solve this. Let the smallest integer be x. Then three consecutive integers are x, x plus 1, x plus 2. From the question, x square plus x plus 1 whole square plus x plus 2 whole square is equal to 110, or opening the brackets, x square plus 2x plus 1 plus x square plus 4x plus 4 is equal to 110. This implies 3x square plus 6x minus 105 is equal to 0. Therefore, using the formula x is equal to minus 6 plus minus under root 6 square minus 4 into 3 into minus 105 divided by 2 into 3. This becomes equal to minus 6 plus minus under root 36 plus 1260 divided by 6 is equal to minus 6 plus minus under root 1296 divided by 6 is equal to minus 6 plus minus 36 divided by 6 is equal to minus 6 plus 36 divided by 6 and minus 6 minus 36 divided by 6 equal to 30 by 6 and minus 42 by 6 is equal to 5 and minus 7. Then x plus 1 is equal to 5 plus 1 and minus 7 plus 1 equal to 6 and minus 6, and x plus 2 is equal to 5 plus 2 and minus 7 plus 2, that becomes equal to 7 and minus 5. Therefore, the three consecutive integers are 5, 6, 7 or minus 7, minus 6 and minus 5. Let's take the next example. The product of the digits of a two-digit number is 12. If 36 is added to the number, a number is obtained which is same as the number obtained by reversing the digits of the original number. Find the original number. Let's solve this. Let the digit at the units place be x and that at the tens place be y. Then the number is equal to 10y plus x. The number obtained by reversing the digits is equal to 10x plus y. From the question, xy is equal to 12, count this first. 10y plus x plus 36 is equal to 10x plus y, count this second. From second, 9y minus 9x plus 36 is equal to 0. This implies y minus x plus 4 is equal to 0. This implies y is equal to x minus 4, count this third. Putting y is equal to x minus 4 in first, we have x into x minus 4 is equal to 12. Therefore, x square minus 4x minus 12 is equal to 0. Or, getting the middle term, we have x square minus 6x plus 2x minus 12 is equal to 0. This implies, taking x common from the first two terms, x into x minus 6 plus 2 into x minus 6 is equal to 0. This implies x minus 6 into x plus 2 is equal to 0. This implies x minus 6 is equal to 0 or x plus 2 is equal to 0. This implies x is equal to 6 or x is equal to minus 2. But a digit in a number cannot be negative. So, x is not equal to minus 2. Therefore, x is equal to 6. Therefore, from third, y is equal to x minus 4 is equal to 6 minus 4 is equal to 2. So the original number is equal to 10y plus x is equal to 10 into 2 plus 6 is equal to 26. Solving word problems using quadratic equations. Part 2. Let's take the next example. The area of a rectangular field is 260 meters square. Had its length been 5 meters less and breadth 2 meters more, the field would have been in the shape of a square. Find the perimeter of the field. Let's solve this question. Let the length of the rectangular field be x meters and the breadth be y meters. Therefore, area of the field is equal to xy meter square is equal to 260 meters square. This implies xy is equal to 260, called as first. Also, from the question, x minus 5 meters and y plus 2 meters are equal. So, x minus 5 is equal to y plus 2, called as second. Now from second, x is equal to y plus 7, putting this value of x in first. Y plus 7 into y is equal to 260. This implies y square plus 7y minus 260 is equal to 0. Or, splitting the middle term, we have y square plus 20y minus 13y minus 260 is equal to 0. This implies y into y plus 20 minus 13 into y plus 20 is equal to 0. Or y plus 20 into y minus 13 is equal to 0. This implies y plus 20 is equal to 0 or y minus 13 is equal to 0. This implies y is equal to minus 20 or y is equal to 13. But breadth cannot be negative. So, y is equal to 13 and x is equal to y plus 7 is equal to 13 plus 7 is equal to 20. Therefore, the breadth of the rectangular field is 13 meter and the length is 20 meter. Therefore, its perimeter is equal to twice 13 meter plus 20 meter equal to 66 meters. Let's take the next example. A train covers a distance of 600 kilometers at x kilometer per hour. Had the speed been x plus 20 kilometers per hour, the time taken to cover the distance would have been reduced by 5 hours. Write down an equation in x and find the speed of the train. Let's solve this. From the question, time taken to cover 600 kilometers is equal to 600 by x hours. The time taken when the speed is x plus 20 km per hour is equal to 600 by x plus 20 hours. From the question, 600 by x minus 600 by x plus 20 is equal to 5. This is the required equation. Now, from the equation, 600 into x plus 20 minus x divided by x into x plus 20 is equal to 5. Or 20 into 600 divided by x into x plus 20 is equal to 5. This implies 2400 is equal to x into x plus 20. This implies x square plus 20x minus 2400 is equal to 0. Or, splitting the middle term, x square plus 60x minus 40x minus 2400 is equal to 0. This implies x into x plus 60 minus 40 into x plus 60 is equal to 0. Or x plus 60 into x minus 40 is equal to 0. This implies x plus 60 is equal to 0 or x minus 40 is equal to 0. This implies x is equal to minus 60 or x is equal to 40. But the speed cannot be negative, so x is equal to 40. Therefore, the speed of the train is 40 kilometers per hour. Let's take the next example. A trader buys X articles for a total cost of rupees 600. First, write down the cost of one article in terms of X. If the cost per article were rupees 5 more, the number of articles that were bought for rupees 600 would have been 4 less. Second, write down the equation in X for the above situation and solve it to find X. Let's solve this. First, the cost of one article is equal to rupees 600 by X. Second, when the cost per article is rupees 5 more, the cost per article is rupees 600 by X plus 5. Therefore, the number of articles that can be bought for rupees 600 is equal to 600 by X plus 5. From the question, 600 by x plus 5 is equal to x minus 4. This is the required equation. From the above equation, we get 600x by 600 plus 5x minus x is equal to minus 4. Or, taking LCM, 600x minus 600x minus 5x square divided by 600 plus 5x is equal to minus 4. This implies minus 5x square divided by 600 plus 5x is equal to minus 4. Or, on cross multiplication we have minus 5x square is equal to minus 4 into 600 plus 5x. This implies 5x square minus 20x minus 2400 is equal to 0. Or x square minus 4x minus 480 is equal to 0. This implies splitting the middle term we have x square minus 24x plus 20x minus 480 is equal to 0. Or from the first two terms taking x common, x into x minus 24 plus taking 20 common from the last two terms, 20 into x minus 24 is equal to 0. This implies x minus 24 into x plus 20 is equal to 0. This implies x minus 24 is equal to 0 or x plus 20 is equal to 0. This implies x is equal to 24 or x is equal to minus 20. But the number of articles cannot be negative, so x is equal to 24.